Benvingut. Gracias a todos los organizadores, a todas las personas que ayudaron a organizar ese evento. Yo estoy muy agradecido de ser invitado de Mark. Pero es un evento internacional, entonces voy a dar mi charla en inglés. Thank you very much for coming here. Today, I would like to talk about a few things that some of you may have heard about, some of you may have not, and some of you definitely have not. I would like to talk about forms and best practices that you can use in each of your projects, right? So I don't want to tell much about me. I think most of you know me. My name is Bernhard Schussek. It's a horrible name for Spanish people, I guess, and for everybody else as well. I'm a Symfony core developer, and in my professional life, I am working as a freelancer and trainer and coach. And on Twitter, you can find me under the name of Web Mozart. Is everybody hearing me well? Like, good? Up there. OK. I will try to speak clearly because I think there's a lot of echo in the room. So one of the questions that I frequently get is, what is the hardest part of Symfony? And the common answer is, yeah, or less like this. Every time I have to debug Symfony 2 forms, I literally die a little inside. Those are really one of the dark sides of Symfony. It's true. Fortunately, there's also an answer to that, which is like this, right? You feel like that before. Usually it takes a long time until you find a solution. At some point, there was this tweet by Jacob. Have you seen Web Mozart's talk? It is the perfect pill for form woes. So it's more like this. It's a PHP elephant, of course. All right, so that's my talk. And at this point, that was the same last time my computer got stuck. This is like an evil video. Seriously. OK, sorry for that. All right, the goal of the form component is to make simple cases possible and to make simple cases simple and complex cases possible. All right, so I think that's well achieved. The simple case is simple. That actually works. All right, so forms are not as hard as people usually say that they are, because most of the simple stuff just works out of the box. And today I want to show you some best practices and want to give you some insight on how you can leverage those skills. All right? So if we look at the workflow of a form in a controller as you use it, it starts in the controller. Then you usually create form. You call the method create form on the controller, which goes to the form factory. And that, in turn, calls build form on your form type. OK, so there you do all the configuration. You get this form builder object. You can add your fields and configure your data transformers and all that stuff. And at some point, that form factory takes the builder, converts that into a form, and returns it back to your controller. All right? In your controller, you then call handle request on that form object. And once you do that, there's a few things happening. The first thing that is happening is that the form will write the request data, the data of your request, into your object. Then it will validate that object by passing it to the validator component, and at last return back to the controller. And if you render your form, for example, if you render it for the first time, or if there were some validation errors, you can also call create view on the form, which will return the form view object and move that object to Twig, to your Twig template, where you will use it to render the form. So you see we have 3 different representations of the form in that lifecycle. The builder, which is used to configure the form, which does all the processing, and the view, which contains all the view information, all right? And I would like to talk about these different parts and best practices in these different parts of the components today, right? So the first is controller, then Twig rendering, validation, updating the model, and building your form, configuring your form, right? So one important thing first, that's my best practices, my personal ones. So it's not the best practices, and there's reasons why you would make things differently in specific use cases. But I would say that in 80–90% of the cases, those best practices work well and are very simple to use in real-life projects, all right? So I will start with the controller. One important best practice that I tell in every new project that I come to, use PHP Storm. Don't use any kind of editor or something like that. PHP Storm gives you so much power and so many possibilities, code generation for so many different cases. It analyzes your IDE for errors, your project for errors, and it tells you about errors before you even run the code. So it's even more complicated ones, right? Use that. Another best practice in the controller is use the action option. Not everybody knows about that option. If you create a form, you can set the action, which is the URL that you're posting your form to, through this option. You don't need to store that information in the template. Because the controller is also the place where you configure the routes if you use annotations, right? Just like configuring the action, you can also configure the method in the controller with this method option. So that will not just put the method in your form, but it will also make sure that your form is actually being executed and processed when you submit it. One bad practice that fortunately not many people are using anymore because it's not possible anymore is passing data to your form type constructors. Who's been doing that? Yeah, I know it's a bad thing. Nobody raises the hand. That's something that was possible and very common, and it wasn't really bad, so bad in Symfony before Symfony 3. But it has some performance implications that you need to know about, and most people don't. So that was one of the reasons why we made that impossible in Symfony 3. There, you have to pass the class name, and instead, you can pass any information that you want to pass to your form through options. So use custom options for configuring your form instances. Here, for example, we have a place order type for placing orders, and we want to pre-select some kind of shipping method. So we could add that option default shipping to our form and fill it from our controller. It's very easy. If you have global settings, I don't know if anybody of you saw Benjamin's talk about feature flags, something like a global flag for stating whether shipping to the US is enabled or not, then you can configure those flags in your service container configuration as a parameter and pass it to the constructor of your form type. All right? In the form type, you can use that flag to enable or disable some functionality like this. The next blog I would like to talk about is rendering with Twig. There's also different difficulties that people usually face, and maybe you too. So one of the questions is, should I or should I not use form? Who uses that in production projects, just out of curiosity? OK. So I guess you probably use some custom form themes to theme your form, and you just output it that way. That is a very good way to do that. But I usually recommend to use it only for rapid prototyping and to stop using that once you customize the HTML of your form. Instead of using form, you can, for example, use form row to control the order of your fields. So there's different form bundles about setting the order of your fields in your form and changing the order afterwards, and it's all very complicated when in reality you have all the power in your template, because in your template you have to control about the order of your fields, and using form row can be a nice way to do that with little codes. Also, you should set any kind of information that is required in the view in the template, right? For example, the label, HTML attributes. Very often, people tend to configure that information in their form types because for us as a PHP developer, it's much more convenient to do so, right? We feel comfortable in PHP code, so we would like to do everything that we can in PHP code. The problem is that this is information that our front-end developers need, and maybe they want to change it. If we do that in PHP code, our front-end developers have no way of changing that information, right? So any information that you need in the view should also be configured in the view. In order to debug your view, use the form debugger. Who has seen and used that icon? Great. I think it's a bit broken in Symfony 3, unfortunately. And if you want to customize your form in more than just controlling the order of your fields, my best practice is to always write custom HTML by hand. Twig is very powerful, so you can use Twig macros, you can use Twig blocks, you can include Twig templates and all that stuff to prevent code duplication. But using those Twig control structures, again, gives power to your front-end developers and designers over changing those things, right? So if you write your custom HTML by hand, the front-end developer can easily add another div with a help text or another class for that label, right? If you just output form and do everything else in a theme, that's very complicated to change for a front-end developer. So in general, my rule is mostly don't use themes. They're really powerful, but they are also really complicated. It's very, very tedious to learn them. It's very tedious to debug them. And if you can avoid them, try to avoid them. Only use them where it's necessary. There are some cases where it makes sense to use themes, especially when you have like big admin interfaces with lots of forms that should all look in a similar way and where you want to have a consistent set of style guidelines. Maybe there it makes sense. But for typical projects, try to avoid themes if possible. Except, of course, for the pre-existing ones. On a recent project of mine, there was a requirement to make a form configurable for the client. So the client could choose which fields they would want to display. They could also order the fields according to their needs. And they could also sort the fields into different groups and different tabs, right? Now, if somebody's using that form and submitting that information to the application doesn't care about that information, like the groups and the tabs and all that stuff. That's view logic, right? It's something that is configured and stored in the database, but it's not really relevant to processing the form. And there was the question how to solve that problem, and I think it highlights one of the parts that is often not used. So in build form, for example, of this form, we would just take all the fields from the database. This is like the field definition that the client is able to change with names and is a field required and all that stuff. And then we would add those fields with their field types to the form. This is simplified, of course, but in general, it works like this. And there's no information about all those tabs and groups and all this other stuff because we don't need it in the form. For processing the form, it's not necessary, right? Still, we need to do that organization by tabs somewhere. And it's definitely not something that I would like to do in Twig, because Twig is very limited when it comes to processing and looping and changing data. So what you can use in such a case is are the two methods build view and finish view in your form type. Who actually overrode that method before of you? Not a lot of people. You should look into that. Build view and finish view are actually called when you call create view in your controller. And it gives you a possibility of taking all these objects that you're passing to Twig and adding information or changing information in those objects. So you can basically pre-process your forms before they are passed to Twig and reorganize them or add some new information from your application. So in our case, we took finish view, took all the tabs configured by the client, and then reorganized the fields, the flat fields, into a deep recursive structure by just looping over those tab definitions. And this solution made it possible to keep the Twig code very simple and very concise. Front-end developers don't usually care about how those definitions are stored in the database, right? They just want to enter it. So what they can do is they can just loop over those tabs, enter their label, output their labels, and loop over the fields in the tabs and render them, more or less. Okay. Okay, let's talk about validation. One thing that I generally try not to do is including assert in your annotations. That is from a time when there was no IDE support for those kind of for annotations. So you had to include or type the use statement manually for every annotation that you wanted to use. And our solution was to include a namespace only once. So use Symfony validation assert or constraints as assert. So it would be easier to use these annotations in your code. Nowadays, there's the annotation plugin for PHP Storm. So whenever you type an annotation, it will autocomplete the annotation and add the corresponding use statement to your file. So in order to make your code more easily readable, I recommend to do that, even though the official docs are still show the other way around. Also, one very nice thing is the callback constraint for validating data. Who used the callback constraint in here? Okay, not so many people. The callback constraint is a constraint, a very powerful constraint that lets you execute custom validation logic. So if you have anything more complex than not null or length or something like that, you can create a validation function or method either in your model, in your entities, or somewhere else, and then add that callback annotation and execute some custom validation logic. So this is an example of adding that callback constraint in the model, in the entity. And here we have this method validate total, which validates the total price of an order, right? And here we compare if the total price of the order equals the total price of all the products, all the line items. And if not, we can add a violation to basically an error, a validation error, right? With this constraint, you see that you can do validation of any complexity. If it's addresses, and you want to validate that a street matches something else, stuff like that. So there's a lot possible with that. Also, I recommend, if your project is internationalized, use message keys. So if you want to publish your website in Spanish and English, for example, it's much better to use a message key than to write the English message and then to translate the English message to Spanish, or the other way around. Because very often in languages, messages can be translated differently in different cases. And if you point the original message here, there's only one translation possible. Also, you can use message parameters to inject information in your validation messages, right? So if you write a custom validation constraint, or if you use the callback constraint, instead of saying just add violation in this method here, you can call build violation with your violation message, and then set parameters to inject information in your validation messages. This is very useful for your users because you can tell them what exactly went wrong. They won't just get the message, this field is invalid, but the email address foobar is invalid because it must contain an ampersand, an at, or something like that. Okay? Or if, in this case, the product total is invalid, you can tell them, I expected the product total to be this, but it is that. So be helpful to your users. Help them at correcting their errors. If you want to validate just parts of your constraints, I'm sure most of you know that you can use validation groups. So for example, if we go back to our example of place order, we might only need to validate the total of the order in certain circumstances, for example, during checkout. And what you can do is you can add the validation group checkout and then validate the model just for that group during checkout. Similar to validation groups, group sequences, you should read up on that if you haven't. You can use group sequences for sequential validation. What does it mean? Basically, group sequences allow you to execute some validation logic, and only if all of that validation logic succeeds, you execute more validation logic. So in this case, only if all the constraints from the default validation group succeed, only then the VAT check, so this is the European tax number, right, is being executed. And what's the purpose? What's the benefit? In this case, maybe our constraints in the VAT check validation group do a request, a web request to a different service for validating the address. And that web request could be expensive. Maybe we are charged for every click, or we are charged for, not click, maybe we are charged for every request, or every 100 requests, or something like that. So we must reduce the number of requests we want to make to that service. And by splitting those validation groups in a group sequence, we can first check all our basic constraints. Make sure that fields are not empty, make sure that they correspond to some regular expression, something like that. And only when all those basic checks succeed, we can move on to the next stage, to the next validation group, and call the web service for validating whether the data is actually valid. Another neat thing that you can do is creating domain-specific constraints. Who of you created a validation constraint before? Nice. So you know some of the stuff that I'm talking about. You can even create very simple domain-specific constraints by extending existing constraints. So if you want to have a constraint product name for validating that a product name must conform to a certain regular expression in different places of your application, you can create a custom regex constraint called product name. And here you can hardcode the pattern that is passed to the regex constraint, because you know that product names must always conform to that pattern. Usually, Symfony tries to find the corresponding validator for a constraint by just appending validator to the name of the constraint. And in order to use the regular Symfony regex validator, you can override that validated by method and return the name of the validator of the base class. All right? So even without writing a validator, you can create a custom constraint very easily and use it in your code. You can also create composite constraints. So if you want to create a domain-specific constraint that does not just invoke one constraint, but multiple, then you can compose them. So let's assume that the product name validator should validate that the product name matches a regex, but it's not equal to certain keywords for some reason. Then you can write your custom product name validator and execute other constraints. So here we take the validation context, validate that our product name confirms to regex and is not equal to some keyword. You don't need to implement all the validation logic that is already solved by those constraints yourself. You can just reuse them here. One important thing when writing validators is to ignore null values. As you know, Symfony constraints usually don't handle null values because you have cases where a value can be null and other cases where a value cannot be null. And in both cases, the value must conform to some constraint if it is set. All right? And yeah, I'm sure you know about that. Okay. Almost the last part of our journey through this form lifecycle is updating the model and mapping data from the form to the model. So as you know, Symfony takes an object when it renders a form, calls all the getters that correspond to the field names in the form on the object to populate that form. And then when the form is submitted, all the corresponding setters are called again to update the object. Now, that's a very simplistic mechanism. And in most cases, in real life applications, that's too simple. Especially if you want to follow maybe domain-driven design or something like that, that mostly doesn't work. So one very simple way to solve mapping problems is by using the property path option. The property path option basically specifies what setters and getters to call in order to get and set a value. So in this case, the property path for that customer.vetID corresponds to or customer.name, here's an example, corresponds to data get customer get name and data get customer set name when the name is updated. And there's different syntax variations for property paths. You can use squared brackets to use array access. So here, items 0 amount would be data get items 0 amount. So this is a very flexible tool to decouple your form from your model. But what about non-empty constructors? What if you want to pass some data when you construct an object? Here, for example, a customer that always needs to have a name and an address. If you have such a case, you can use the empty data option of your form and pass a closure that creates the new object. So by default, this empty data option will just return a new object, but you can change it to return a new object and pass data from your form. This technique only works in cases where you create new objects, but not where you change existing objects. So this is a very common case if you have value objects, an object that is immutable, and anytime that you change the object, you actually want to create a new instance of that object. Such value objects usually look similar to this. Here is an example for money, where I pass an amount, and I can get the amount. And it's important that money is immutable, because if I take 2,000 euros and give it to you, then you want to make sure that 2,000 euros remain 2,000 euros. I mean, yeah, we never know. But you want to, if somebody else says, okay, my 2,000 euros are now just 100 euros, then you don't want to have your money changed, right? So that's why value objects are usually immutable. It's also very simple to deal with value objects. You can just pass them around, and you don't have to worry about any side effects from anywhere else, because you know this value is always going to remain that value. With a form, it's a bit difficult, because Symfony forms don't support value objects out of the box. Some examples here would be a product ref type, like a value object for a reference to some product, where you store the ID and the name of the product, for example. And this would be a value object product ref, but in your template, it's a string. It's the name of the product. Or the money type, my money type, where you have that money, and again, in your templates, you want to enter your money as number or a string or something like that. You can use data transformers in Symfony to support value objects. So basically, what we want to do is we want to convert our value object to a type that Symfony expects and back with the data transformer. And one important thing to keep in mind here is that a data transformer doesn't always have to be a separate class. So what I usually do when I implement a type that needs some transformation, I just implement the same data transformer interface in the same type, all right? And you can add the methods of that interface and then add model transformer this. So it keeps things very simple. If you need data transformation in many different types, but just in one type, then it doesn't make sense to move that logic into a new class. And here you would do something like this. Transform would take a money object and convert it to a string or integer. And reverse transform would take the submitted value, the string or integer, and convert it back to the value object. It's actually a very simple technique. Now, there's another use case when it comes to mapping to your model, which is non-standard methods. So if your methods aren't called set something or get something, for example, here, relocate address. This is commonly happening when you want to try to apply domain-driven design in your project, and you want to use the ubiquitous language in your model. A customer usually, you don't set the address of a customer. You relocate or you move or something like that. If you want to support non-standard methods in your form, you can use custom data mappers and custom data mapping. Just like before with the data transformer, you can implement data mapper interface in your type, and the data mapper is basically responsible for executing this logic, calling getters and calling setters with updated information of your form on the model. After implementing the data mapper interface, you call setDataMapperThis in build form. And then you have two methods, map data to forms, where you take the existing customer and map it to the fields. So for example, here forms address, set data, customer get address. And the second method is map forms to data, where you take the updated forms and merge their data into the existing customer object, if there is one. So you see that this is passed by reference, that's important. So here we would call customer relocate with the new data of the address field. Again, it's a very simple technique actually, and it allows you to have very fine-grained control over how exactly you want to update your model after submitting a form. Right, the last part of that journey is the build form method. One important thing that I think that everybody should know is all the different options of choice type. Because choice type is also extended by entity type and by document type and many other types. And all the options that you have in choice type can be used everywhere in all those types, right? So you probably know that like with one of the later, like 2.7, I think, there was a change in the choice type option choices. We switched the label and the value in this array around. And this means that in your choices, you can select from any kind of data type. You cannot just select from strings and integers, but you can pass objects to your dropdowns. And then your customer can choose any of these objects, and your application will receive the selected object. Right? That's very, very convenient. Before Symfony 3, you need to make sure to include choices as values to enable that flipped functionality. There's a lot of other options that we added back then. One very useful one is choice label. Choice label lets you control how a choice is rendered in your view. And it accepts a few different kinds of data types. One of them is a string, a property path. And you can, for example, if you pass the property path title, then the choice type will call getTitle on each of the choices. So in this case, our choices are objects, like with the entity type, there we also have objects. We want to call getTitle to render them in the view. If that logic gets a bit more complicated and you want to add data from different fields to that view, to that label, you can pass a closure. And that closure receives the choice and returns the label for that choice. So here we could humanize, for example, the type of the selection and render that. And all these things, like passing property paths and passing closures, are supported in different options of choice type. Another one is choice value that converts a choice into the value that is rendered in the option. And that's very useful if you use that value in JavaScript. If you want to access some data of the option in your JavaScript, you can pass it by setting the choice value option and pass it to the template this way. Again, you can pass a closure here. Similar thing, the group by option. Again, you can pass a property path or a closure. And this group by option controls how options are grouped in your view. Again, here we call getCategory, getName to group all those different options. So this is very powerful. You should definitely learn about it because it saves you a lot of time if you have these use cases and gives you a lot of power. Talking about field dependencies, often stated use case that is hard to solve with the form component are fields that depend on other fields. Classic example, country and province. And what you should do here to solve such cases is use event listeners. But one thing that many people don't do is adding those event listeners on a field level. So here, we take the country field, and on that field, we add the event listener post-set-data. That means not after the form has been populated, but after that field has been populated. Now we can add some logic, add another field, and Symfony will just continue to process that other field. All right? So that's the crucial thing. If you have such a use case, add the event listener to the field that you want to respond to. Okay? Same can be done for post-submit. So get country post-submit. After the country field is submitted and changed, you can execute some logic. And add province field can be some closure where you add this province field and where you can already access the country that is set on the form because it's an event listener for the country field, right? And depending on that country, do something in your province field. Of course, if you have multiple dependencies, this gets a bit messy, but still it's possible. You can solve it. It's not a use case that is impossible to solve. All right. That was my part about best practices. And to finish off my talk, I would like to talk about forms and all those best practices with two different architecture styles. Because I think many times the question is, should I do it this way? Should I do it that way? There are so many different ways that I could solve my problem. What's the right one? So one architecture, you could tell it, is CRUD, create, read, update, delete. I will start an example here, a contact, some contact information, first name, last name, email, phone number, address, maybe some accessor methods. And you want to store that, a list of contacts or different contacts in your database and use that information. CRUD, create, read, update, delete, gives your customers a very simplistic access to those contacts. So they can open a contact, edit all the fields, save it. They can create a new one, edit all the fields, and they can delete it and create, read, and read it, of course. It's very easy to handle such a case in your controller. You would get some contact from a repository, or even use a param converter, of course. Pass it to the form, handle the form, and then if the form is submitted, you would save that contact back to the repository, to the database, or wherever you store it, right? It's very easy, it's very simple. One thing that I like to do is writing strict signatures. So PHP gives you power over doing some consistency checks in your code, like type hints, or adding equals null for fields that are nullable, or not adding equals null for fields that are not nullable. With PHP 7, you even get more type hints for scalar types, so it's very powerful. I usually like to include those type hints in my model. Of course, then you have a problem, because if a value is submitted through a form that doesn't correspond to that type hint, then Symfony fails. The simplest case is if the field is simply empty, then Symfony will try to call setAddress null and fail. What you can do here is twofold. You can add the constraint not null to the address field. In this way, you show a message to the user that the address field may not be null and that they should select an address, for example. And the second thing is you must prevent Symfony from calling the setter if the value is null. And you learned how to do that before. You can write your own data mapping logic, implement data mapper interface, and one way is quite straightforward, but on the other way back, when you update the form, when you update the data, you can actually check if the address is not null, and only if it's not null, you set the address on the object. So I usually do that. It's very simple code. It's a bit more to write, but it gives you a lot of control and flexibility. And if this value is null, the form will display an error message due to the constraint that we added to the field. Okay, CRUD in general is very simple. It's suitable for many cases, but it's not suitable for any cases that involve any kind of business logic. So if your business is more complicated than just reading and updating data, and I guess it is, otherwise you wouldn't be using Symfony, I guess, then CRUD may not be the ideal choice. Another option that is in everybody's mouth at the moment is DDD, domain-driven design. It's very nice. Also in combination with CQRS, which is command query requests segregation. Responsibility, sorry. And the idea behind domain-driven design is to take your customer's domain and understand your customer's domain and model it more or less identically in your model. Use the same terms, use the same concepts, use the same processes that your customer employs. And I won't go into details about what DDD is exactly. I will just show you some hints of how you would usually use that in PHP or implement it in PHP. So one thing that is very useful with DDD is using a command bus and command systems. So anytime somebody is doing something to your system, changing something, they're actually giving a command to your system, right? They're telling the system to do something. So you would model that command as an object and then pass it to a command bus, and the command bus would make sure that the command is passed to some kind of command handler. That command handler does basically it's basically the conductor, right? It takes the command and now it knows, okay, we need to fetch some data here, we need to fetch some data there, and then we need to pass all of that stuff over to some aggregate, and the aggregate is the object that contains the business logic. So for example, our contact contains the business logic for modifying contacts, right? So here's an example. Command bus dispatch modify contact with a set of field values. That's what you would do in your controller. Then you would have some command handler for handling that command, which gets the contact from the repository, and maybe it's also getting a field repository and getting all the fields for the field values that somebody wants to set on that contact. So remember, this is the use case that we had before, where a contact can have a variable set of fields that is defined by the user of the application. And then once the fields and the contact or the field definitions and the contact are selected, we can call modify on the contact with the field definitions and the new values. And in the end, the command handler calls flush to flush the contact back to the database or data store. And in the contact itself, you have all the business logic for modifying the commands. The contact now has the fields, the field definitions, and the new values, and you can check if the values correspond to the field definitions and many more stuff. So all the business logic gets inside that class, that aggregate. And the question is, where do forms fit in with that kind of architecture? And there's a little trick that you can do. I told you before about data mappers. But usually we would think about a data mapper mapping data from an object to a form and mapping the data back from the form to the same object. But in reality, that object doesn't have to be the same object. So when we display the form with our contact information, we can take our aggregate, the aggregate root, and map the data of that aggregate root to our form and display that data in the form. But when we submit the form, we don't want to change the aggregate root because we can't. We want to have a command and submit that command to the system so that it can be handled. So what we can do is we can map the data back to a new object, which is the modify contact command, right? And in your controller, you can get that command from the form and dispatch it to your command bus, right? So again, to repeat the workflow, when a form is displayed, you take the existing contact object from the database, pass it to the form, process the form, and at the end, the result of the form is the command that should be executed in the system. You can even, depending on the things that are selected in the form, you can fire different commands or return different commands to the controller in order to be dispatched. So that's already the last slide of my presentation. Almost. A bit summary about DDD and CQRS. CQRS, by the way, would be solved in exactly the same way, except that you would use the view model and map your view model to the form instead of the aggregate, the write model. So using DDD and CQRS can cause DDD without CQRS, DDD with CQRS. can cause a lot of boilerplate code in your application. It's a lot of code that you have to write, but it also is a very well-structured way to encapsulate your business logic. And since it's so close, or try to be held close to the domain of the customer, it also helps you at understanding what the customer actually does in his daily job. Now, of course, the question for a project is, what should I do? How should I do it? Should I use a CRUD? Is it sufficient? Or should I do a DDD design? Or should I use CQRS? I didn't talk about CQRS today because it's like a whole nother subject that I don't want to read up on it if you're interested. And here the important thing is that it's not an either or. You don't have to implement all your application as CRUD or all your application using DDD models. You can choose. If you have some parts that are really simple, data entry and output, you can use CRUD. And if other parts in your application are more complicated, have more business logic, you can use domain-driven design for that. And if some part is even more complicated or has maybe very high performance requirements, then you can use CQRS, all within the same application, right? Some parts like this, some parts like that, some parts another way. Just choose for each part the architecture that suits the information best. All right, that was just a little excursion about DDD and CQRS. If you're interested, read up on it. I will also publish the slides, so if you have time to digest that, you can look at it again. I just wanted to provide you some hints and clues at how to solve things. And in general, if you embed your own data mapping code in your forms, then actually form handling is not so complicated. So it can be quite simple if you do it right. But of course, if you have a very complex use case with lots of dependencies and lots of logic that needs to be executed, there's unfortunately no way to reduce that complexity in the form. The only thing that you can do is try to reduce the complexity in your project or in the business domain. Find an easier way to model a problem. All right, thank you very much. I hope you enjoyed the talk and get some information from that, and enjoy the rest of Symfony Catalonia. Thank you.